I welcome you in this lecture. So in last lecture, we have seen different features of Google Colab, and we have seen how to read data sets in Google Colab, and there are three different options available that you can utilize. And the best way that we think that if you want to update your file regularly, so the best way is to keep your all file in Google Drive and directly read your data set through Google Colab. So first you need to mount your Google Drive, and then we have seen how to read GitHub project in Google Colab. So these have been covered in previous lecture. In current lecture, I will discuss popular dataset repositories. There are certain available repositories that we can utilize to read a dataset for different type of problems. We will also discuss on following dataset: crop recommendation dataset, Pima Indian diabetes dataset, California housing prices dataset, and MNIST dataset. So these four datasets we will be using throughout the course, and we will perform several experiments utilizing these datasets. So what are these datasets that we will discuss, and what are the different parameters and why these are important? So we will discuss. Now, working with a dataset, so how you can from where you can get the dataset. So there are certain places where you can get dataset. Popular open dataset repositories are that is UC Irvine machine learning repositories. Here you can see the link of accessing their dataset. And the very popular one, that is Kaggle dataset, that we have seen in last class. And specific datasets as well. Like suppose if someone is working on a particular experiment, right, and he or she has created his or her own dataset and make it available on their website or on their own web page, or even they have uploaded it to certain some separate repositories. So you can access those dataset as well. Other pages listing many popular open data repositories are Wikipedia's list of machine learning datasets, so that you can visit. So these are certain repositories where you can get the dataset. Let me show you how can we access dataset from Kaggle. So here you can see these are certain options. Once you will open the Kaggle, here there is option datasets. Let me press this one. So once you will press this dataset option, here you can search the dataset. Like I am using Pima Indian diabetes. So it will give me several similar datasets, and I will use this Pima Indian diabetes dataset. And here you can download. Once I will press it, so it would be downloaded. Or the other option is I can directly access the dataset via Google Colab by utilizing this URL. Right? Copy it, and in last class I have told you how we can directly access the dataset utilizing Google Colab. So you can see here, and there are certain several information related to this dataset. And even you can see certain code as well. If since several researcher and author have utilized this data set to their own experiment, so they usually share their code as well, right? So several type of information you may get. And if you want to set some search some other database, again go to, suppose I am searching California data set, California pricing data set, housing pricing. So I can again search and then go to that data set. Here you can see there are certain, this is particular data set, and there are certain options here, how many views are there and how many downloads are there, So you can see 136,000 downloads have been made. So how much popular these particular data sets are, right? And so several type of information are there. You can visit this page. So we have seen how you can get the data set from Kaggle. Similarly, you can use Erwin machine learning repositories. Now, the very first data set that we'll be utilizing throughout the data science course is crop recommendation data sets. So what is it? This data set allows the user to build a predictive model to recommend the most suitable crops to grow in a particular farm based on various parameters. So this data set actually having a special dependent feature, that is the which type of crop you want to grow. So it utilizing machine learning model, you can predict which crop is suitable, right? You want to predict which crop is suitable. So this dataset was built by augmenting datasets of rainfall, climate, and fertilizer data available for India. This dataset is available on Kaggle dataset. So just type crop recommendation dataset and you will get this dataset. So I have already included the URL for crop recommendation dataset. The dataset consists of 7 independent variables. So we can divide the whole, parameters into 2 separate type of parameters. Some are independent parameters, or you could say independent features or independent variables, and there could be some dependent variable, right? So in this case, there are 7 in this particular data set. There are 7 independent variables, or you could say features, and 1 dependent variable, that is label. Label is containing the information about which crop, type of crop, whether it is apple or rice or wheat and so on. This data set contains 2,200 records. As far as feature of crop recommendation dataset are concerned, so I have already told you there are certain independent features and one is dependent features. And as far as independent features are concerned, we are having N. There is a feature N, that is actually ratio of nitrogen content in soil. Similarly, a feature is P, that is ratio of phosphorus content in soil. K stands for ratio of potassium content in soil. And it also contains temperature in degrees Celsius. It also having information about humidity, that is relative humidity in percentage, pH value of the soil, rainfall. So these are independent features. And dependent feature is label, which is actually suitable for crops. If you will observe, I have included here few records of crop recommendation dataset. So you can see there are labels, which is rice, chickpea and maize and so on. So there are actually 2,200 records in this data set, and it is a multi-class classification problem. Since multi-class or binary class, actually we will discuss what is binary class classification and multi-class classification. In binary class classification, we are having only 2 values. And in multi-class, we are having several classes. Like in this case, we are having class of rice, chickpea, maize, similarly wheat, apple and so on. So there are several classes exist in this data set. So it's a multi-class classification type of problem. And there is a correlation between feature. Actually, correlation says how a feature is related with other feature, right? Value of 1 is specified that a feature is totally correlated with other feature, right? And if you would observe, the diagonal values are 1. It means in the same feature is fully correlated, right? So that's why it is 1. Like rainfall is correlated with itself, rainfall. So obviously it is 1. And as far as other features are concerned, so there are certain values here you can see. So if the value is very high, it means it is highly correlated. If value is very low, it means it is low correlated, right? So that is the meaning of correlation, and it has been depicted here using heat map. So it's very I would say a very innovative way of displaying the correlation between features utilizing the heat map. Now, the next dataset that we will be utilizing in our course is Pima Indian Diabetes Dataset. This dataset originally from National Institute of Diabetes and Digestive and Kidney Diseases. The objective of the dataset is to diagnostically predict whether or not a patient has diabetes. So, actually this dataset contains only 2 values. Either a patient is having diabetes or the patient is not having diabetes. So it's a binary classification problem. The number of download is 463,000 times it has been downloaded. So it's a very popular data set. And I have already included here a link to download data set. The dataset consists of several medical predictor independent variables and one target, that is dependent variable, in the form of outcome. So there are some independent variables and dependent variables. All patients here are females at least 21 years old. So that dataset actually contains 768 records of female patients who are at least 21 years old. These are independent variables. Pregnancy is number of times pregnant, then glucose level, blood pressure, diastolic blood pressure, then skin thickness, tricep skin fold thickness, insulin value, 2-hour serum insulin value, BMI body mass index value, diabetes pedigree function, age. So these are independent features, and one is dependent variable or feature, that is outcome. So either it is having 0 or 1. So 266 out of 766 are 1. It means 266 records are having 1 value. It means 266 patients are actually suffering from diabetes, and rest of the records, that is 500 records, are non-diabetes patients. So these are certain records of Pima Indian Diabetes Dataset. I have included very few records. So like pregnancies, number of times pregnant, that lady had conceived the pregnancy, then glucose level, blood pressure value, skin thickness, and so on. So, and this is the outcome. Actually, we want to predict utilizing different models whether a patient is diabetic or not. So that would be the target when we'll discussing the modeling in separate week. Here you can see the correlation between features through heat map. So obviously I have already told you the diagonal would be having 1. It means that feature is fully correlated with itself, and otherwise there are certain other values. So if a feature is very much correlated, so it would have high value. If it is very less correlated, it means it would have very less value. So in our training purpose, we can, if a feature is very much correlated, if 2 features are very much correlated, so we can exclude one feature, we can drop a one feature. So there is no need to include both the features if both are very much correlated. So that we will discuss in detail when we will be discussing the modeling part. Now the next data set is California housing prices dataset. This dataset contains median house prices for California districts derived from the 1990 census. It serves as an excellent introduction to implementing machine learning algorithms. The objective of the dataset is to predict median house value. You know, it's actually a regression type of problem. It is not a classification type of problem. What is classification type of problem and regression, that we'll discuss. So it's a regression type of problem where you need to predict the value, actually the housing mean house value, median house value. And as far as this download of this dataset is concerned, so 136,000 times it has been downloaded. And here you can find the link of that dataset. So this dataset consists of 9 independent variable and 1 target that is dependent variable, that is median house value. And total record, it actually contains 20,640 records. So it is having a huge number of records. And these are independent variables. Longitude, so a measure of how far west a house is, a higher value is farther west. Similarly, it is having latitude value. Housing median age, so median age of a house within a block, a lower number is a newer building. So if a block is containing lower value, it means it is a newer building. Total rooms within a block. So suppose the whole data set is divided into different, the whole California housing data set have been divided into different blocks. So total rooms of total number of rooms within a block, total bedrooms, total number of bedrooms within a block. So it says the value in a particular block. Suppose the society have been divided into several blocks. So it contains the total rooms in a particular block, total bedrooms in a particular block. So it is storing all this information. And there are certain more independent variables, that is population, total number of people residing within a block, households, total number of households, a group of people residing within a home unit for a block, median income, ocean proximity, location of the house with respect to ocean, sea. And as far as dependent variable is concerned, so this one is the dependent variable, that is median house value. So median house value for a household within a block. So we want to predict the median house value. So that is the target. So it is a regression type of problem where we are not classifying, but we want to have certain value. There are certain records of California housing prices dataset. So you can see here ocean proximity, near bay and inland, near ocean, and so on. Similarly, median house value. So we want to predict this value, actually median house value. The target is to predict the median house value, and these are other independent variables. Now this one is the correlation between features. So you can see here the diagonal value obviously would be 1, and it is the lighter one is highly correlated. Like in this case, you can see it is very correlated. It means the total bedrooms and total rooms, these are very much correlated. So we can check whether our prediction would improve if I am dropping total rooms, or if we are dropping total bedrooms, and so on. So it is very good data set as far as pre-processing is concerned. So we can explore it, and we can by utilizing different pre-processing techniques, we can improve the performance of our prediction. Now the fourth one, the last dataset that we will be utilizing throughout the course, that is MNIST dataset. MNIST dataset is a set of 70,000 small images of digits handwritten by high school students and employees of the US Census Bureau. Each image is labeled with the digit it represents. So each image, suppose the digit is between 0 to 9. So the whole data set is containing digits from 0 to 9 only. And there are different ways of writing 0 to 9, right? So each student and employee are writing digit in different ways. This set has been studied so much that it is often called the hello world of machine learning. So it is very important, I mean, people have utilized this data set in such a manner that now it is called hello world of machine learning. The objective of the data set is to predict the image between 0 to 9. Again, it is a multi-class classification type of problem. Number of download, 127,000 times it has been downloaded, and this is the link of data set. As far as features of MNIST dataset is concerned, each image has 784 features. This is huge number of features. Why it is so? Because we are storing image in 28 cross 28. It is very less actually, in 28 cross 28 pixel. Let's say if our image is 128 cross 128 and so on. So it would have huge value of number of features, right? So each feature simply represents one pixel intensity from 0 to 255, right? So according to the intensity, it actually shows what is the image right? We consider CSV format of the dataset. Actually, there are different format of MNIST dataset. Some in the form of image, and the researcher have also utilize that image dataset to create CSV format also. So we are utilizing CSV format of this dataset. The dataset contains two files, one for training dataset and one for testing dataset. So when you will download this MNIST dataset as per this link, the link that I have given, so you will be available with two different files, one for training dataset and testing dataset. So they have already separated the training dataset and testing dataset. So a training dataset contains 60,000 records and testing dataset contains 10,000 records. So as a whole, 20,000 records are there in this dataset. These are independent variables. Since I have already told you, total 28 cross 28 different features are there, right? So the very first feature is 1 cross 1 and then 1 cross 2 and so on. I am not including all the features because it is not possible here. So 1 cross 6, then 1 cross 7, 1 cross 8 and so on. Similarly, after 27 cross 28, 28 and so on. So there are these much of independent features. Then the dependent feature is between 0 to 9. So this one is the records of MNIST dataset. So if you will observe it, so there are total in training samples, there are total 5,923 zeros are there. It means it's a different format of writing zeros are there, right? Students have written students have written zero in different formats. So there are 5,923 zeros in that data set. Similarly, 6,742 ones and 5,958 is twos and so on. So total these categorization are there in MNIST dataset. These are sample events that I was talking about. That zero is someone has written some different format, one has been written in different format, two has been written in different ways and so on. But your the target is to how efficiently you identify the digits, right? Because students and employees have written in very different format. So just to summarize, we have seen the popular dataset repositories, and the very popular dataset repository is Kaggle dataset. Kaggle also provides you very some other facilities as well. You can enroll to a different competition as well, and you will learn several innovative ways to solving a particular problem. So I would suggest to enroll on those competitions. We also discussed a following dataset, that is crop recommendation dataset, Pima Indians diabetes dataset, California housing prices dataset, and MNIST datasets. So these datasets will be used throughout the data science course. So I will suggest all of you to download this dataset or keep it in your repository, whether in Google Drive or in your personal machine. So I'm stopping here. Thank you so much, and we will meet again in next lecture.